to. That's fine.
I just introduce you. So welcome everybody, those in person and those online. We're lucky to have Sophie here today to present a project she's working on and potentially going to join us in the fall for a master's. Us from Dalhousie Chemical Engineering. Really happy to have you here today, and I'm looking forward to hearing about your project.
Yes, I'm happy to be here. Thanks for having me. So I recently graduated from chemical engineering at Dalhousie and just recently started my first job post undergrad at High Latitude Energy Consulting, and dove right into this project called Kluane Lake Research Station, and it's renewables and hydrogen energy project is our title. So I'll just go over kind of the status of that project and how it might work into a possible master's. Yeah, I'm from the Yukon Territory, moved out to Halifax, but now working remotely for High Latitude, which is a company based in the Yukon but spanning across the north. So it's nice to have those roots to my home. Start by just going over this. I'm going to talk about the research station, project vision statement, who we have on the team, and helping out with us with that, and existing sustainable infrastructure and system at the station currently, and then the planned integrated hydrogen system for this project, as well as our project approach and current stage, and then a timeline where we're at. So Kluane Lake Research Station has always aimed to be a model system, and they set some new targets for achieving sustainable operations, including the reduction of their current greenhouse gas emissions and achieving greater autonomy and efficiency in terms of energy use. So as part of this initiative, the station introduced this project. It's a pilot project with the aim of demonstrating that renewable energy production at the site created in those peak generation months in the summer can be effectively used, transferred over and stored to operate the station in the winter months. So a little bit more about the station. It's located up here in the Yukon. You can kind of see in the top map, but zoomed out there near the Gulf of Alaska. And then closer down, you can see it in relation to Whitehorse. So it's 220 kilometers northwest of the capital of the Yukon, which is Whitehorse, on the traditional lands of the Champagne-Ojak and White River First Nations. And the extreme elevation difference, so at the site, is very unique for research. As you can kind of see, it's on the cusp of that massive mountain range known as the Kluane National Park. Highest mountain in Canada is located there, Mount Logan, and it's got a huge Arctic circumference of mountains in there, and really goes from boreal to extreme Arctic tundra pretty instantaneously, right? And the research station's right on the edge there at Kluane Lake. Yeah, and it's operated by the Arctic Institute of North America, AINA, within the University of Calgary. And a little bit about AINA, they're an educational nonprofit with a mandate to advance the study of North American and circumpolar Arctic through the natural and social sciences, arts, and humanities to acquire, preserve, disseminate information on physical, environmental, and social conditions in the North. Next, our project vision statement. So it's a bit of a mouthful. Kluane Lake Research Station, Renewables and Hydrogen Energy Project. We decided to cut it down, just call it Kluane RH2. Sounds a bit nicer. The main kind of 4 points here, the project will demonstrate how a remote facility may operate year-round on renewable energy when paired with hydrogen storage. It produces a viable, scalable, renewable energy storage concept, including valuable insights and data to inform and shape the future of northern community initiatives. So if we go back here, actually the neighboring communities like Destruction Bay and Burwash Landing are on similarly isolated microgrids heavily reliant on diesel. So you can see how it applies directly to the neighboring communities and then others across the north. This kind of concept of seasonal storage and getting away from diesel. It'll offer promising pathways, so like I said, to transition from emission-intensive diesel generators common in these northern communities. And it will consist of energy source, solar PV, most likely, energy storage and generation in the form of a hydrogen electrolysis and fuel cell, and the energy demand is the facility for the station. Altogether making a clear case for seasonal energy storage via hydrogen. Project team, so myself coming from High Latitude, I only started with High Latitude in October, so pretty recent, but I'm doing something right. They gave me a coat. Yeah, it's a new company formed in spring of 2020, kind of a partner company with one of the leading solar energy construction companies in the Yukon, known as Solvest. And they lead the renewable, this company is to lead their renewable energy feasibility market north of 60. So we're going to provide remote areas, communities, and projects that primarily run off diesel generation with access to high-level feasibility studies. We have a lot of projects currently going on in Yukon, in all the territories. Yeah. So we want to prepare proponents with confidence required to make these renewable energy investment decisions and drive projects from the feasibility stage to deployment in the Indigenous, public, and private sectors. Yeah. The other main partner on our team is Thor Hydrogen. They're an industry specialist focused on deploying the next generation of equipment to meet current energy needs. They're also a new company located in Kimberley, BC, but they have a unique skill set of over 20 years of experience in oil and gas that they're now trying to transition and go towards the obvious and needed transition needs to happen towards renewable energy and proven renewable technologies. So they're a great help. They bring a lot of detailed insight, bringing the right people together for this project, such as third-party engineering companies, and giving us broad connections across the hydrogen industry. Other support at the moment, we're in early stages, so this kind of preliminary phase, in addition to AINA, we have some strong support coming from the station itself, including a researcher in sustainable infrastructure at the Kluane Lake Research Station in Penn, been a valuable partner. The Yukon government through the Innovative Renewable Energy Initiative and the Energy Solutions Center located in Yukon have also shown support already in this early stage. So getting into more of what's actually going on at the station itself. So I guess the first thing to talk about is, as I said, the station has already made moves to become a model microgrid and a model research station. Being remote and off-grid, they have set goals to achieve and sustainable operation in multiple ways. So the first thing to note is they have an off-grid containerized growing system at the station. So they're the host of this project called AG 1054. It's Yukon's first ever off-grid containerized hydroponic farming system, located on mile 1054 of the Alaska Highway, hence the name. And that's kind of a little graphic made up by that project. A little bit more about this. It's known as a crop box, installed by a local company in the Yukon. It's a 40 by 8 foot container designed to improve the efficiency of farming methods with hydroponic technology. It's designed to operate year-round regardless of the external weather conditions, and some studies were done concluding that it's much more efficient, using 90% less water and 80% less fertilizer than conventional methods. And yeah, it really has been a valuable source for facilitating a blueprint for growing fresh greens in a resilient and resource efficient manner. Just addressing that key issue of food security issues in the north, avoiding having these greens shipped up from Whitehorse or much farther down south. So this is some nice images of what that looks like inside. I'm not sure these are actually from the exact container at the station, but they all kind of look the same. They're really cool inside. They have a ton of LED lights, and they usually get to this point of, I've been in a few in my life through work, so usually get to this point of fullness, and we've got a lot of things there. And this is from the outside at the station. You can see this is during installation a few years back. There's the shipping container crane putting it in. And then you'll note here they have a solar array on that roof. And there's also a few other solar arrays just not shown in the image, but that's one view of the station on Kluane Lake. So the existing energy system is comprised of 3 separate areas of solar. So they have 2 roof mounted solar arrays and then 3 separate ground mounted arrays for a total of 128 panels. 4 inverters. They have a DC coupled system with a battery bank and generator, and then that's powering the microgrid load, which is the main loads are just the building electric power and the hydroponic unit. So this is just some specs about what's actually going on there. They have the 128 panels, 2 different types because it was installed in 2 separate phases. They did 64 panels and I think half the battery bank first, and then added some more a year later or 2. And, yeah, we've got 38 kilowatt hours of storage at 50% discharge, and they're less lead acid batteries out there. So this is another view. It's a nice showing all the solar arrays and the surrounding buildings. So currently, this station only operates in the summer months. And that renewable energy we're seeing actually doesn't consistently support the current load throughout the summer. So generators engage frequently, battery banks only effective of some short-term storage cycled every day. And so more durable storage is required. And this is an infographic I made up just showing a simple look at what the system with the new hydrogen system and some new renewable energy might look like. So starting at the bottom, we are considering expanding / replacing the battery bank if we can find a nice repurpose of the old batteries locally or some recycling option. Then also looking to add additional renewable energy generation, potentially wind, but definitely solar to feed into the DC side. Then moving over to the hydrogen side, there's to simply kind of put system with an electrolyzer, water management, oxygen management, and then compression, hydrogen storage, and fuel cell. And then part of, obviously there will be the discharge of that thermal energy through the fuel cell that will be dealt with. And then they're also considering adding a second seasonal growing container. The first one was done by Cropbox, which is a company, but the second one will be, if it happens, designed by a local company, designed and installed by a local company called Baker in Whitehorse. So the project was formally kicked off in November, so only a month ago, very early stages still, but the buildup has been significant. There's been discussions around this for a year, just kind of putting all the ducks in a row to get funding and start it. Just managed to come together, but current stage is feasibility. And being in the project team, I feel as though feasibility stage will be the most crucial. It's going to be very in-depth. We want to emphasize that this is a gateway project. It's going to lead to a lot of data. We can analyze the successes and the downfalls of what goes on when it's installed and throughout design, but really building a knowledge base of, okay, what available technologies are they? How do these things interface together? Doing an in-depth study on hydrogen storage methods. So there's going to be a lot of conceptual stuff going on and probably beyond maybe what's necessary for this specific project, because we want to build a knowledge base to be able to make this scalable, a modular thing that can be applied if, when and if future initiatives come up that are similar. So yeah, it's going to come with a conceptual phase, and this feasibility will leak past decision gate 1 into actually assessing what's available to us, what we can install, what we can design, into preliminary feed, and kind of end with the decision gate 2, where we are making some design decisions. We're at that select on the top, and we've assessed what we studied, and we make some preliminary decisions. So the feasibility study in that right now, and basically it's going to look at, as a more broad case, the an energy system with the following characteristics. So it builds on the energy capacity of the existing microgrid, allowing for increased operational demand. We want to kick it up to year round. There's future loads like the second crop box and additional scientific instrumentation, some like dryers and stuff like that at the station we want to add. It's going to effectively integrate with that existing energy system. So yeah, looking into what's the status of those, the health of that battery system, where would the new solar go to really maximize round trip efficiencies. Going to complete the green energy system, reducing and eventually eliminating fossil fuel storage, expand on existing photovoltaics, and evaluate the benefits of integrating vertical axis wind at site. And then it includes green hydrogen production for season storage and creates the potential for year-round operation with exclusively renewable energy. The further analysis aspect, kind of looking beyond just this project of feasibility, will require in-depth analysis of energy storage with a focus on hydrogen. The battery study will go on, but the focus here is hydrogen. Compressed gas or alternative chemical methods such as ammonia will be looked into. A general study on renewable energy partnered with hydrogen for seasonal storage. How is that interfacing, optimizing the system's potential for scaling replication, and like I talked about, those directly neighboring communities and all across the north, kind of looking at how it applies. And then a framework. We want to develop a framework for effective energy management system, enabling efficient data capture and operation of the facility. So can secure data that would be useful, easy for analysis on the system performance and carry over. And that kind of comes back to the idea of conducting an academic study in the future, a proof of concept, potential master's project for myself. And these are the deliverables we're looking at this early stage right now. So we kind of started with speaking at the station, forming a design basis, went into data gathering to figure out what the load is, what the future load will be, what the winter load looks like, thermal, then starting on some preliminary modeling and achieving that decision gate 1 where we can identify, assess viable design options for power generation, energy storage, the delivery, controls, water management, and modularity and scaling aspects. And then the feasibility study will also go deeper once we have that into safety and risk management, environmental assessment, financial analysis, and as I spoke about, the extended analysis of energy storage and hydrogen adoption. Also, already speaking with third parties to get peer review and design assurance, and then reaching out to the communities nearby, getting some community engagement, how we feel about this project, and then early stages of regulatory requirements and permitting, having those early conversations. So when we reach decision gate 2, we really have all the full picture. And this is the timeline. So I keep talking to people about the feasibility study and how great it is, how much of a gateway project this will be, and how we're building that knowledge base. But everyone always wants to know, okay, but when will it be built? And the timeline is ambitious, and for this type of project, it can be. Solar's been installed before. The hydrogen is a big focus, but it can. This is the timeline we've worked out. So you kind of see that feasibility started very recently. Gonna hopefully wrap that up by the end of April, and then start on front end design till the end of 2023. Design and procure, do some offsite fabrication at the beginning of the summer of 2024. And I guess I should note that in May it's still cold. They wouldn't want to get up there maybe until June. So then June to the end of the year, try to do the installation and operation and maintain that system. So that's what we're looking at. And I guess the main reason I reached out to Kluane and UVic is because I noticed this, this whole timeline has potential to fit inside a master's. It's if everything goes to plan, and I knew I wanted to do some some masters, some getting back to school and getting into research, but it seemed like a good opportunity to take this, which is really going to have some very interesting data, some very interesting insights, and apply it in that way, have an industry collaboration. And then just to finish off the opportunity, so the implications of this study, as I've said, will definitely resonate beyond the fence line of the research station. We're going to set the standards for regional adoption of similar energy grids, create kind of this knowledge base that allows for a broader application, whether that be communities within North or remote industrial settings like mines. And given the imperative to eliminate our reliance on those carbon emitting sources like these diesel generators, up in the North, there's significant potential for hydrogen to become that principal energy carrier for northern seasonal storage in Arctic regions. Yeah, that's all. Have any questions?
I have a question about, so you got electrical load, what's the heating load like? How is that?
Yeah, so it's a good question. Currently in the summer, I think it's very low. They have like some electrical baseboard heaters and stuff. And that's incorporated into kind of our load, but an element of this feasibility will be looking at where do we put the fuel cell to best transfer that heat, and how is it going to be integrated into the existing buildings. And I think it will involve basically advising a new heating system for the winter that incorporates the thermal energy produced in the hydrogen process. But they do currently have just electrical heating, but in the summer, they only operate in the summer. So that's a big, the thermal operation, I guess, is a big component. We're looking at hydrogen right now as providing that electrical load for the winter, knowing there's potential for that thermal to be used, but kind of sticking to the electrical loads concept, assuming that there will be no additional electrical loads for heating. That'll be a question to address. And especially in placement, heat exchangers need to be close to where they're going to supply heat, and how we can most effectively disperse that.
Actually, very interesting to see this happening. It's actually, downstairs, the current notes, another student, 20 years ago, I actually had this Irene project, which it's done in a lab, the integrate wind energy, but it's actually, it's done through a programmable power supply.
Mhm.
And so they're kind of trying to mimic what's happening in intermittency in the renewable energy. And they did have, actually still have this fuel cell in there, and the power equipment, I think the kernels what I'm talking about. And actually it's good to see that you actually could be doing this in a container, to support this crop plots is quite interesting.
Yeah. I
So
think
that's actually, but I think like what we learned from that is that kind of simulated the environment actually is the overall efficiency. But I think apparently economy is not one concern in this gateway project, I suppose.
Yeah.
Because at that time, I think 20 years ago, the efficiency of this alkaline electrolyzer is like 70%, and the efficiency for this fuel cell is like 50, 40, some. So all together, you lose 2/3 of the energy in there. So it's not economical, but it's doable actually to demonstrate this. But my question is actually, what do you consider for the fuel cells, the real components, and also the electrolyzer? Actually, I think it's not trivial, but I don't know. Have you looked into that yet? To electrolyzer, fuel cell, I think you can buy many, but it's not many choices for electrolyzer.
Yeah, I think we began thinking about it. We have like a few manufacturers, a few people that do it, and we want to reach out. We're finishing up kind of coma modeling and design basis right now to be able to go to those companies, and we're communicating with Ensoul, early stages about the design, and working with them. So it will be a third-party collaboration for those key elements, especially the electrolyzer. Yeah, we haven't really gotten into it yet, just a month in, but that's what I'm most excited for, I think, is to get into that technical design. And I appreciate what you said before, it's maybe not the most economical, but this project's really going to be a demonstrator.
Yeah,
There's a
I
lot of
understand.
support at the Arctic Institute, or the Arctic Northern research. So they're really pushing for this to be that pilot project kind of base case. How does it work? And it's northern, like it's so isolated, so maybe not the best thing, but getting the maximum efficiencies and then saying this is necessary for this specific case. Obviously, we're not doing hydrogen seasonal storage in a major city, but yeah, for those isolated grids, having and it's really important to note, like you said, it's powering that crop box, kind of solving another sustainable resource obstacle that also exists. So renewable energies are leading to other solutions that are relevant.
Well, of course, after you finish this, probably you want to scale it up to see how you can where they can scale it up. That's about, I mean, how much power consumption for this one container?
It's a good question. I was just talking about that. It's less than 10 kilowatts.
Okay.
It does make up about half of the research station's load though in the summer, when it's like at full capacity.
Right.
So it's significant, and they're going to add another one in the summer, which they just told us recently. So a lot to consider with that crop box.
I see that the solar panels, quite a few there.
Yeah,
It's each one you consider like 200, 300 plus. And that's not, you can.
yeah. There's so much
Yeah.
space for more solar, and wind is showing promising support for the battery system. So that'll be interesting to figure out how that fits in as well.
I'm wondering why at this early stage of the project, it seems that you're leaning pretty heavily in the direction of solar. And given that, at this kind of latitude, you've got quite limited sunshine hours in winter, and the year-round supply is kind of the objective. Why is wind not more favorable?
Yeah. it's a good
Is it just the
question.
nature of the resource, or?
I think it's a few things. So because we are looking for, we're going to make hydrogen in the summer with all our excess renewables, and there is the element of the midnight sun up north. So there is really 4 months of the year where that solar is absolutely negligible in the winter, but in the summer there is a sustained, very long days, lots of sunlight, and the low temperature actually makes those panels more efficient. So there's a good argument for solar in the north, despite having those dark winters, especially in this application. And then on the wind side, first of all, the station is installed next to an airstrip. So there's some limitations in terms of installing wind, just height restrictions. But it is being looked into. I think the main reason it wasn't a primary, but it's now becoming an aspect we're going to research, because the modeling has been very promising for wind, for strong support, but also there's just more familiarity with solar. There's been hundreds of solar projects in the north recently, and not as much wind. There's just more uncertainty, more risk, given that it hasn't been done as much. I expected that. And I guess another kind of component is the wind is all year round, and we want to use it as a support, but we don't want it to replace the hydrogen aspect. So it's kind of that consideration. I think it's being looked into, but solar will be that main excess summer to make hydrogen for the winter.
Okay.
Yeah.
So the hydrogen storage is really a core part of the.
Yeah, as I said, I think we're gonna weigh the options between what best demonstrates this pilot project, like this idea of hydrogen for storage in the winter, what kind of balances between that and the actual most efficient system, because the most efficient system might be a ton of wind and a ton of solar, a tiny bit of hydrogen, but we want to show hydrogen's potential for supplying the winter load, like a significant portion of it. So
If I understood correctly, you were looking at having a mixed hydrogen system with fuel cell and compressed storage. Is that sort of so that raises some sort of important control questions that your control system would need to handle that balance between effectively dispatching the fuel cell versus running the turbine. And how do you have some direction on how that would be managed? The sort of trade-off between those two systems?
I think at this point, no. And I'm more involved on the battery solar side of the project, coming from high latitude. But I think that's something we're looking into in this feasibility phase. We are starting to, reach out to companies and Thor's starting to make some preliminary design decisions. But I guess the infographic was a very simple, compress, store it, and then use it. We're missing some key elements in there. But it's a good question. Be part of a question to be answered in the next 12 months.
In sense of like how big a tank you're actually looking at?
I do not. I did my capstone in like hydrogen stuff as well, but it's all theoretical. I'm really excited to see like an actual system, an actual electrolyzer, something happen, because it all has been theoretical. So I don't have a graph of how much of that gas will actually.
Oh, no, this sounds like very, very cool. I don't know if maybe someone else here as well might know. Have there been any pilot projects in northern communities with hydrogen storage and like hydrogen in any sense? Like, I'm not aware of any.
I've been told no. I think high latitude is kind of, thinking this is the first of its kind. So not that I'm aware of, and people are really excited because it does have a kind of first step towards those type of things.
Yeah, I'm very curious to see the results. And the timeline is very aggressive, just like interesting to me. Like, I mean, it's good, like they get done, and even as it's like a pilot project. So one question I have was, as far as like, I don't know how much you might know about this, the funding and stuff. Is it like there seem like there are a lot of partners involved and that sort of thing? This will inevitably be a very expensive project. It's gonna be hydrogen, compressed storage, and that sort of thing.
Yeah.
Like how, like, do you have an idea of how, like, what the scale of it is going to be, and how, like, is it definitely happening to some degree? Like, will there be hydrogen stuff, and then just the scale of it is the question.
Yeah, I guess I don't want to get everyone's hopes up, but from our perspective, it's definitely happening, and some kind of assurances of that just include the aggressive research side, like the Institute at University of Calgary is pushing for this. There's an anonymous donor pushing for this with some cash, and the kind of support I have listed there in the Yukon has just been on the feasibility phase, but because we haven't formalized the next set of funding, but it's all kind of set up on the Research Institute side. So we feel confident because I think a limiting factor of doing these feasibility studies is, okay, we did the feasibility study, it's actually so expensive. Or we did it could be this expensive, or it could be this, like there's a huge kind of contingency there, but given we have kind of some parties that are interested in supporting it in it almost no matter what kind of scenario, the initial estimates and like the pre-feasibility, I don't know what the numbers are offhand, they were kind of looked at as like, okay, doable. And there is a lot of support, I guess, is the short answer.
Yeah, but it's really neat. I've worked on a few handful of projects in northern communities with like for like RCP or military facility type things, and like they will go pretty aggressive. But like hydrogen is not being on the table at all, and I think part of that is just there needs to be these kind of tested like pilot projects.
Yeah.
That have been done to some extent, like we think they'd be most interested in that. But like, even when they might look at like biomass or that sort of thing, which is like available sources might be those wood preserve, like ancient wood basically, which seems like very limited, like you have a limited, I mean, there's a lot of it, I guess, but in the end, this seems like where in those sorts of situations where like cost is not as much factored in common movies, it does seem like a very like, interesting. I'm very excited to see the
Yeah.
pilot project finally go forward. I guess. Because you need something to report to.
Yeah, totally. And it's a really great setting for it, like doing it a pilot project for kind of, yeah, let's say like gateway project for providing that data that it isn't available, doing it at a research station where everyone's in the mindset of we have to do it to see what happens. It's a good setting for it. It's a beautiful location. I'm gonna go up there next week or next couple weeks.
And logistically, you can drive there, right? You
Yeah.
don't have to fly in.
Yeah, you can drive. It's like a great location in the summer for hiking and rafting and stuff like that. It's a really beautiful park. So
I'm
And
saying in
if-
terms of transporting all these, like you're not having to pay to have a Hercules
Yeah,
fly in
no.
or something.
the fact that we can drive there is pretty nice, and it's not too far. It's 2 hours.
Because container, the
Yeah.
container has
Plus-
to be shipped there anyways.
Yeah,
Yeah.
some of them are like boat accessible, right? And Yukon has more road connectivity than some
Yeah.
of the territories.
Yeah, totally.
You had a little mention of ammonia in there. How seriously are you considering other?
I don't know.
bits
I
and
think
pieces?
that we just want to have that base that we've looked into all the possibilities. I don't know enough about ammonia to really say the seriousness of it. It would just, add more elements to the system.
Yeah.
More process. But yeah, I think just having the knowledge base, if it's not applicable here, at least we've done some look into it, and maybe it will be more applicable in the future as those technologies come out, because people are starting to look at ammonia more.
Yeah.
So,
Yeah, we've been looking at, that's what I put the volume, right? Because
mhm.
you store liquefied hydrogen, depending on the temperature that it wants to boil.
Yeah.
So much you kind of lose over time. It's small, so it likes to leak.
Mhm.
Be interesting to know like what a giant vat of ammonia would look like versus tanks of hydrogen, what the
Yeah.
logistical challenges, the advantage of efficiency for sure you take a hit on, but
Yeah, I'm really excited to observe that hydrogen system, especially, and I think the storage, the seasonal storage, but like really that storage aspect is going to be a big part of the study. Like we are going to, like for those key components, as I said, coordinate with third parties, but looking at the best way to store it is kind of very big, very specific to this case, and exploring that method.
Just following that, I think you might have problem finding a small device to store hydrogen or like electrolyzers is all I usually feel like huge.
Yeah,
And for your demand, I don't know whether you can buy commercial products. Because all those commercial ones actually quite big Siemens there, huge
Yeah.
electrolyzers. With overkill, you can still use that, but it's overkill system.
Yeah.
Because actually you can think actually it's not much. It's just the storage of hydrogen. Actually, we have this kind of race in Taiwan. I went to 10 grams of hydrogen. It's not much. It's good enough to power a racing car for 1 hour. In the perk with a driver is sitting there. So 10 grams actually is, so storage actually, if you have this 10 kilowatts, I think it's not a problem. It's the scale you probably, well, for gas storage, it's okay, but it's actually, it's electrolyzer, you might want to buy small ones. I don't know whether you can find, or you can build it if you want.
yeah, yeah.
And
Interesting.
also, ammonia is something also you have to consider, you have to release, get the hydrogen back. So in that sense, probably you take another device to do that.
Yeah,
And also this actually speaking of which you can consider this the liquid organic hydrogen carrier, the kind of liquid base, you can dissolve it into that. They, again, it's a catalytic reactor. So you have to kind of let hydrogen out again. Then you need another device to get it out. But newer design of electrolyzer kind of can pressurize that to fairly high pressure, so you don't need a compressor.
Get it part of the way there.
Yeah.
Yeah.
So, so yeah, but I think all this can be done by modeling. You can simulate all these things. That can get
Mhm.
the sizing. Especially the sizing is the first thing you have to consider.
Yeah.
Yeah, I think people haven't really pushed the seasonal storage stuff. We kind of
No.
throwaway comments about this, right? But
Yeah.
to actually do that is,
And this is the perfect kind of, it's actually applicable here.
Yeah.
We're already starting to think about other hydrogen projects up north, so it's gonna be great, like if we can push this timeline and get that insight. Yeah, make those decisions on, yeah, providing that knowledge base and then making those decisions, we can always go back to why we made them reassess for a new system. Yeah.
I have a question, like not, I don't know the process very well. Is there a lot of heat generated in electrolysis? Like a lot, or is it-
Yeah, significant, I would say.
it's low grade though, typically.
Yeah. It should be used for sure, I guess.
I'm just, yeah,
Yes.
just thinking, because like one thing that doesn't, it often does not make sense. Or it might sound counterintuitive. And permafrost is using that, but if you did some sort of like long-term thermal storage, whether they are like renewables or something else, maybe like I don't know, some other storage. But again, you're mentioning it seems like availability of renewable energy sources is very high in the summer and not. The heat they'll be needing in the winter for the winter.
Yeah.
More probably than, maybe not more, but it sounds, I guess you didn't know for sure what the profiles look like, but I would imagine the heating loads are going to be extremely high.
Oh, that'll be significant. Yeah, I guess we are working on providing the electrical load solely, assuming no additional electrical load because of heating. So we're gonna, look into how much heat is available, how much heat will be needed, and how to supply that, but it won't be electrical, I guess, is the answer to that question. And like it won't affect the actual load. The actual electrical load is supposed to be relatively similar in the winter because we're not doing the heat. But yeah, it'll be a big part of the actual, is this actually going to be off like completely?
So you're assuming that systems are turned on, but no one's like living there, so you only need minimal do not freeze heat or?
Well, I guess we're just saying the heat's going to come from somewhere else. Like it's not
Okay.
going to be electrical. And the electrical load, their business operation is actually still going to go down in the winter. So theoretically, not considering heat, the summer, the load will be very comparable to.
Well, that kind of answers my question, but I was gonna say, I don't think it makes any sense to heat it electrically in the winter.
Yeah.
If it's off the grid, they'll just use gas or something. 'Cause
Yeah.
It would just be insane.
Maximizing the efficiency by utilizing any available heat from hydrogen, but yeah, it won't be electrical heat.
It's burn hydrogen.
Mhm.
If you have enough.
Right, yeah, I think we want to do some, like excess hydrogen. Can we power some of their research devices on hydrogen, or like hydrogen powered drone? I don't know. We're gonna look at like beyond, because not every year is gonna be the same. There might be more use cases for that locally.
And you can always combust ammonia too in normal engines.
Yeah,
That as well.
yeah. I think that'll be a whole other study because this is focused on the electrical load, but it might be a whole other component of taking the data from this, what's available, and how we make the heating system most efficient.
Yeah, well, I mean, like you could say, I'm not gonna have a fuel cell, I'm gonna have a gen set that runs off of ammonia or hydrogen even. 'Cause I know I think BMW has these dual fuel cars, right? Where it has a hydrogen tank, but it's still a internal combustion engine, you just switch to burning hydrogen.
Yeah, that's
There's a
interesting.
number of, there's one over Vancouver Hydro that does that for semi trucks.
Mhm.
So you can, it's not as efficient as a fuel cell, but it's another way of using the energy to
Yeah.
get waste heat.
Yeah, you could have like something added in the future.
People even blend hydrogen to diesel.
That's right. Yeah, that's what Hydro does with their system in truck.
Yeah.
You have to be careful with like flame temperatures and things like this. But
I think interesting, like we're still shipping a lot up to the station. As you said, it's driving, so maybe investing in a hydrogen vehicle to provide that fuel for the station, stuff like that.
one in the chat, is that someone with a question online?
Oh,
No, that was the initial call.
Okay,
No question from the online.
we should ask, is there anyone online that wants to ask a question? Either,
Raise their hand.
yeah, raise his hand, unmute.
I've got a quick question. I don't know if you guys can hear me.
Yes.
I'm just kind of curious. It looks like you're planning on using hydrogen to replace the diesel generator. I'm assuming you're kind of planning to remove the generator altogether. Have you looked at all into whether there's options for having bulk hydrogen delivered and in the chance that you run out of hydrogen before you're able to start producing again in the spring?
I guess the short answer is we're not going to take the generator out. It's going to need to be there for backup power, and it might be an integrated, like a slowly iterative process where eventually we install what might work, and then it still needs to kick in the generator. So we adjust the design over the years and eventually take out that. But we haven't considered having like a hydrogen shipped up or serve. I think while I say that the project is very likely to go through due to funding, it will come down to if we get all the funding in the world, we kind of install this as aspirational case where it's completely green. But if we don't get it, we're still going to go for it, but then maybe keep that generator involved and then eventually get off it. So this phase, I guess we haven't made any of those decisions, but it'll depend on the actual kind of limitations going into construction, the next design phase.
Makes sense. Well, very cool. Looks like a really interesting project.
Question chat from Pierre Iacchetti. I'm curious about your plans for modeling the system. Could you speak to this? What software / model? What are you going to look at and scenarios?
Yeah, so right now we're doing some preliminary modeling in Homer. Homer Pro, they have hydrogen capability, and you can input solar, like connect it with other modeling, like PV6 models. So it's a good tool. I think that was one of the main things we researched at the beginning of the feasibility phase is how are we going to model this system? So right now it's Homer, but we might still be looking into other softwares in the future. If that answers the question. Is there anything else?
Not for now, but it's still
How much thought so far has gone into eventually approaching some of the First Nations communities with a design like this? Because that seems to be the obvious next use case, right?
Yeah, so there's a lot of communities surrounding, and High Latitude does have some projects in partnership with First Nations communities. So there's definitely going to be a natural segue into bringing our knowledge gained from this into those projects. Yeah, I think that'll be kind of part of the community engagement aspect as well on the traditional lands of two First Nations groups. So gauging interest and just building a knowledge in those communities about what's going on and how it will be applied. It's already in the works, kind of.
Do you have any rough thoughts about what the cost of supply would be compared to the existing systems?
No, I guess not. We haven't really dug into any financial analysis, but more.
I imagine for a pilot project, but yeah.
Yeah,
Yeah.
it's a lot of, we do have a lot of solar going up and has been going up in communities in Yukon specifically, and the other territories to offset diesel. But yeah, this versus current system, solar has a, 10-year payback, usually pretty good especially with the government incentives, but this is a whole new financial thing, so we'll see.
Right, good. Good. Okay, well, thank you very much. Appreciate
Yeah, no
that.
problem. Thank
Awesome.
you, guys.
Thank you.
Thanks. Thanks, everyone.